Case studies of 8561 aluminium alloy during the mechanical stir processing at a high temperatures. The current research examines the structural and mechanical properties of sheets made from 8561 aluminium alloy using the dynamic stir process after being the treated perpendicular direction rolling comprehensive characteristics stripwise investigated temperatures longitudinal treatment orientation tensile test and grain boundary was also performed alternative temperatures and different strain rates to assess the ductile mechanical properties of crystallization substance and ensure distinction from the parent material caused by the dynamic stir process. The tensile test temperature and strain rate from 380 degrees Celsius to 780 degrees Celsius employed parallel study materials behavior at the high temperature. The same scope was used to examine the fractures and surface specimen evaluated various temperatures. The dynamic process stir become increasingly popular with current research in instance where the structures of welded product is critical. The approach is improve efficiency, most increase the useful dynamics compared to conventional welding result in significant reduction in the severity of deformation and residual stresses. The tensile test, stress strain. The curve represents the behavior of the alloy's mechanical characteristics with those of parent metals, exhibits outstanding yield stress, outstanding the tensile ductility characteristics when the viewed from the broad perspective, even though the deformation then causes the metallurgical results like outstanding since the material is exposed to the harsh circumstance through the dynamic stir process. The outcome remarkable on the other those of parent material in the regions. The exhibits normal behavior of short material which considerable changes in grain size result mechanical reaction of the center being greater than that the parent material and heat temperatures. The material that makes up next exhibits tensile behavior compared to the material later directions. The material in reinforcement particular showed the dramatically improved strength and ductility as a direct result of a dynamic stir process, which generated a structures that was both uniform and extraordinarily fine. The tensile tests were performed at temperature range from 50 to 200 degrees Celsius, investigated how the material react to high temperatures. The difference in the material responds to actual stress and strain. The strain required to fracture material increases temperature rises, while flow stress decreases until temperature is 200 degrees Celsius. The tensile stress varies with respect to the strain different testing, the temperature shown in figure 3. Also, at the high strain rates, grain reinforcement, the material will happen. The individual grains are crystal with the material become small and more uniform. The grain reinforcement can improve the mechanical properties such as strength and toughness. These are the tensile strength strain graphs. Finally, the SIM analysis is completed. Due to the extraordinarily high load fracture ratio tested the material attained the heat to high temperature. These alloys showed the extremely favorable superplastic behavior being the treated stir process. The conclusions finally, using optical morphologicals were able to analyze the microstructure formed by the procedures, identify how it affected the grain structures The material were tested longitudinal transverse tensile strength. The demonstrated sufficient degree of sensitivity higher strain rates. The implies of friction strain material may be capable superplastic behavior at a various temperature of strain rates. This case study revealed the microscope mechanics behind the heat deformation as well as friction included the fixtures.